Hello boys and girls, welcome to Mrs. Bandu's Math Movies. This movie is for my Course 2 class, Lesson 4-7, Graphing and Writing Inequalities. Okay, so in this section our objective is going to be to graph and write algebraic inequalities. First we'll talk about a couple of definitions and then go through some examples together. First of all, an inequality is a mathematical sentence that contains greater than, less than, greater than or equal to, less than or equal to, or not equal to, which is an equal sign with a slash through it. Okay, the first four are the ones we're going to be dealing with in this section, but this truly does indicate an inequality as well. A solution of an inequality is any value that makes the inequality true. Okay, and what you're going to find for inequalities is there is a set of values that makes it true, beginning with a particular number on the number line, and then either things that are greater than that number, less than that number, greater than or equal to, or less than or equal to that number. So it's very similar to what we're doing with equations, yet it has some inequalities have some unique characteristics as well that we will be exploring here. Okay, so identifying solutions of an inequality. Find whether each number is a solution of k is greater than -6. And then you have a list of numbers here, -8, -6, 0, 3, and 7. Test each value by replacing the variable and evaluating the sentence. Okay, so first of all, -8 is greater than -6. That's false. Okay, because -8 is to the left of -6 on the number line. The next one would be -6 is greater than -6. This is false as well because they're equivalent. So they can't, in this case, it's not, makes an untrue statement. 0 is greater than -6. This is a true statement. 0 is to the right of -6. 3 is greater than -6 is a true statement. And 7 is greater than -6 is a second true statement. So we actually have three true statements, a third true statement. So we know that we see from this that the numbers 0, 3, and 7 are solutions of k greater than -6. The numbers -8 and -6 are not solutions because when I substitute them in, I get false statements. So basically, if it makes it true, it's a solution. If it makes it false, then it's not a solution. Pretty cut and dry right there, or pretty black and white, so to speak. Okay, let's look then at graphing inequalities. Graph the solution of each inequality on a number line. Okay, so here they've actually already have the graphs done, but pay attention to what's going on and let's examine these. We have r is less than or equal to 2. So we're going to use a solid circle at 2 to show that r can be equal to 2. We also shade the number line to the left because it wants numbers less than 2. So numbers less than or equal to 2 would be a solid dot at 2 and then a shaded in number line to the left of 2 where all the numbers are smaller than 2. It's a solid dot because of this equal bar says that, oh, it could be equal to 2 as well. Similarly, we have m is greater than -5. Here we're going to use an open circle at -5 to show that m cannot be negative 5. In other words, we want to go right up to negative 5, but we don't want to include that number in our solution. So numbers greater than negative 5, this is negative 5 right here. We have that open circle or open dot right at negative 5. We're shading to the right because we want to indicate all values greater than negative 5. Okay, so from this you want to know when you should be using the solid dot, when you should be using the open circle. Solid circle is if you have less than or equal to or greater than or equal to. Open circle for greater than or less than. Okay, you might want to make a note of that. So I'll just jot this up here. Okay. Remember when we graphed equations, we just put solid dots at the answer, and the answer was one specific number. Again, this is what I was saying. There are many numbers that I could put into here that would be true. This shows you all of those numbers that would make the first inequality true, r is less than negative 2. This shows you all the numbers that would make m is greater than negative 5 true. You can always test that by taking one of those numbers in the shaded area and substituting back into the inequality that you're given. All right. Back to the next page, page 3. Let me move that so you can see number 3. Not page 3, but number 3. Write an inequality for the graph. Okay, so you're given a graph, and again, what you need to do is examine the graph and see what you see. Since the circle at 1, this is the number 1, they're just typing in every other number, is closed, negative 1 can be a solution. Okay, so we would write y is greater than or equal to 1. Since the graph shows values that are greater than or equal to 1, we're going to use the greater than or equal to symbol. Okay? Solid dot at 1, solid circle at 1, shading to the right. So equal to 1, greater than 1. So in a case like this, you're simply examining the graph and writing a statement that tells about what the graph looks like. Number 4. You must be at least 18 years of age to vote in a presidential election in the United States. Write an inequality for this requirement. Okay, so let's say that when your age is greater than or equal to 18, you're allowed to vote in the presidential election. So if A is equal to the age in years, okay, we can write that A is greater than or equal to 18, and you just pull that together in one nice little inequality. Okay. All right. So that's it for our examples in this section. Please review these examples. Think of any questions you might have. Complete the quick check. Bring in any questions you may have for those as well. I look forward to seeing you in class very soon. Thank you.